Hello everyone, I'm Poonam Sharma, your science teacher. Welcome you all another important session of Atoms and Molecules chapter. So children, in previous class, I have discussed about atomic mass, molecular mass and their formulas, and I have already explained mole concept to you, which is very important part of this chapter. Now in today's class, first I'll recapitulate mole concept, then I'll discuss very important questions from this chapter. So let's begin our class. As I told you, mole is a unit in which we measure the quantity of particles, atoms or molecules in an element. So as we know, atoms are very small particles. We cannot measure them. So we need some particular unique quantity or unique term to measure them. And that is mole. So we measure atoms, molecules or any charged particles, whether it is cation or anion, in mole. Like we need different units for distance, for weight. So we use different units for temperature. But if we want to measure the number of atoms, molecules or particles present in an element, we use this unit mole. And 1 mole is equivalent to 6.022 into 10 raised to power 23 Avogadro's number. And this Avogadro's number given by scientist Avogadro, and this is equivalent to 1 mole. As I explained you in previous class as well, like one pair of shoes. If we are saying one pair of shoes, it is equivalent to one pair is equivalent to 2. It means it has 2 shoes. And if we are saying 1 dozen bananas, it has 12. So if we are saying 1 mole of atom, 1 mole of atom, it is equivalent to 6.022 into 10 raised to power 23. And if we are saying 1 mole of molecule, again it is same. 1 mole of molecule. It is also equivalent to this one. And if we are talking about 1 mole of particles, whether 1 mole of particles, and these particles can be cations or anions, it is also equivalent to this Avogadro number. And when we write this, see here one more term I have explained, that is molar mass. I think this is clear to you. So Avogadro number is equivalent to 1 mole of atom, 1 mole of molecule, 1 mole of particle. So they all are equivalent to 6.022 into 10 raised to power 23 Avogadro's number. And when we want to find out, suppose 1U of hydrogen, U is a unified mass, or we can write atomic mass unit. The number of atoms present in an element represented by AMU, atomic mass unit, or simply we can write U, that is unified mass. So 1 U of hydrogen has 1 atom of hydrogen, or we can say it contains 1 gram of hydrogen or 1 mole of hydrogen. So they all are equivalent to 6.022 into 10 raised to power 23 atoms of hydrogen, which is Avogadro number, which is represented by symbol MO. Now let's take an example of this water. Here water is here, which is a combination of 2 molecules of water and 1 of oxygen. So when it is formed here, there are total 4 molecules of hydrogen, and here is 2 molecules of oxygen. Now just add the, first we'll take out the molar mass. How can we take out this? Hydrogen just is atomic mass, which is 1. So 2 2s are 4. So we multiply by this, it is equivalent to 4. And now we have oxygen, 1 molecule of oxygen to form 1 molecule of water. Now this water. Now if here 2 is written, what is the atomic mass of oxygen? which is 16. So multiply this 2 with 16 and we'll get 32. And when we add these two, these are atomic mass of hydrogen and oxygen which are present in it. When we add both the numbers, then we get 36. So 36 U of water molecules are present. Now, what is the relationship between mole, Avogadro number and mass number? See, if we are writing 1 mole of carbon atom, as we know that the 1 mole of carbon atom is equivalent to 12 gram of carbon. Because as you can see here, carbon, its atomic mass is 12. So it is equivalent to 12 gram. So when we are writing molar mass, so in place of writing U or AMU, we simply write grams. And if we are writing atomic mass, this is 12U. And if we are representing it in a molar mass, so instead of writing U, we simply write G. So this is the relationship between atomic mass, molecular mass and molar mass. So we can represent molar mass just by writing G. And if we are talking about hydrogen, 1 mole of hydrogen atom, it is 1 gram of hydrogen atom. It is 1U, or we can write 1 gram. This is atomic mass, and which is equivalent to Avogadro's number, which is 6.022 into 10 raised to power 23. And 1 mole of any particle, that can be any ion, cation or anion, it is equivalent to relative mass, and then we can write in just gram. So if we are writing 1 mole of molecules, suppose we are taking an example of water, which I have just explained to you. So if we are writing water, first we'll calculate its molecular mass. How can we calculate? So 2 plus 16 is equal to 18. So this is molecular mass of water. And what is the molar mass of water? We simply write 18 gram. So just see, only you can write gram instead of U. That is unified mass. So we'll get molar mass. So this is the relationship between atomic mass, molecular mass and molar mass and Avogadro's number. Now, I'm just giving you one more example. For example, atomic mass of hydrogen is 1U. So its gram atomic mass is 1 gram. See, only G is written in place of U. And 1U hydrogen has only 1 atom of hydrogen. 1 gram hydrogen has 1 mole atoms, which is equivalent to 6.022 into 10 raised to power 23 atoms of hydrogen. And if we take an example of oxygen, here we are taking atomic mass number because we are considering only elements, atoms of oxygen only. So it has 1 atom of oxygen. It means 16 gram of oxygen has 1 mole atoms, and which is equivalent to again 6.022 into 10 raised to power 23 atoms of oxygen. Or we can say that 1 gram 1U is equivalent to Avogadro's number. So this I have explained to you. Okay, now calculate the number of moles of the following. I'll just take example of one question in which you need to calculate number of moles. So first question is 52 gram of helium. See, number of moles represented by N, given mass small n, and molar mass represented by capital N. Now, if you need to write formulas, see number of moles, here it is written, number of moles is equal to given mass upon molar mass. So first you need to calculate the molar mass. The number of moles represented by small n, and given mass represented by small m, and molar mass represented by capital M. and given number of particles, which are Avogadro's number, represented by capital N. Okay, given number of particles by N, and Avogadro's number, it is NO. Now, atomic mass of helium. So first you need to calculate atomic mass of helium, which is 4U. If you look at this table, helium, it is 4. It is written here, it is 4. So that's why I have written 4 here. And atomic mass and molar mass, they both are same, only the difference of unit. So in place of U, we can write gram. Now, according to the formula, N is equal to M upon M. This M is the given mass and this capital M is the molar mass. So, small m, 52 gram of helium. It is already given in the question. So, I have written 52 here. And molar mass, we have just calculated, which is 4 gram. So, by dividing these two, we will get number of moles. I hope this question is clear to you. So, when you want to find out number of moles, so you will use this formula. Number of moles is equal to given mass upon molar mass. Okay, now question number 2. 12.044 into 10 raised to power 23 number of helium atoms. Find mole from number of particles. And we know that 1 mole is equivalent to Avogadro's number, which is 6.022 into 10 raised to power 23. And according to formula, if you need to find out the number of moles, and if Avogadro's number of particles are given, so you need to write this formula, given number of particles divided by Avogadro's number. So simply we just write, this is NO. It is represented by this NO. Now, number of particles are given in the question, which is 12.044 into 10 raised to power 23. So, I have written here, which is 12.044 into 10 raised to power 23. I'll write here again, into 10 raised to power 23. And Avogadro's number, so we know that, which is 6.022 into 10 raised to power, again 23. So, it is 20. Now, dividing these two numbers, we'll get this answer. So, number of particles are 2. And one more thing, when we need to find out the moles of gas, and the formula is moles of gas. See, 1 mole of gas is always equal to 1 mole of gas is always equal to 22.4 liters at STP. And what is this STP? It is standard temperature pressure. Because we know that if we increase temperature and pressure, the volume of gases also increases or decreases. So if we want to measure the volume of a gas in moles, so we use this formula, moles of gas is equal to volume of gas, which is in centimeter cube divided by 22.4 liter, or you can write 22400, but it is at STP, that is standard temperature and pressure. So this is how to find out the moles of gas. Now next question is, how many moles are present in 4 gram of sodium hydroxide? So first of all, you need to find out the molar mass. And if we are writing molar mass, so we'll write gram molar mass. Because sodium hydroxide, formula of sodium hydroxide is NaOH. And when we are representing molar mass in case of atoms or molecules, we'll write gram atomic mass, gram molecular mass. So here we are finding the gram molecular mass of this compound, because compound is given. So we need to find out the moles in sodium hydroxide, which is a compound. And this compound is a combination of molecules. So we'll write gram molar mass. So how will we find out gram molar mass? Again, NaOH. So it means it has three elements. Na, which is sodium, oxygen and hydrogen. Sodium, the atomic mass of sodium is 23, oxygen is 16 and hydrogen is 1. And when we add these three numbers, we'll get 40 gram. This is the gram molecular mass of NaOH, which is sodium hydroxide. And we need to find out how many moles are present in 4 gram of sodium hydroxide. So first, 40 gram of sodium hydroxide is equivalent to 1 mole, as I told you earlier. So therefore 1 gram of NaOH is equivalent to 1 upon 40 mole. And we need to find out in 4 gram. So simple, 1 upon 40 into 4 and we'll get 0.1 mole. That's simple. Now these are the formulas which you remember where if you want to solve all the numericals. Remember all these formulas if you want to find out molar mass of a substance. So molar mass of the substance in grams upon number of moles. If you find out number of moles, mass of the sample which is given in the question upon molar mass. And if you need to find out number of molecules or atoms or molecules, number of moles multiplied by Avogadro's number, and 1 AMU is equivalent to 1 gram upon Avogadro's number. And if you need to find out number of gram atoms, so mass of element upon atomic mass. Number of gram molecules, mass of substance upon molecular mass. So these are the formulas which you keep in mind when you want to solve all the numericals. Now there are some questions, very important questions from this chapter. So let's discuss those question answers. Question number 1 is, sample A contains 1 gram molecule of oxygen molecule and sample B contains 1 mole of oxygen molecule. So we have two samples A and B. In sample A, 1 gram molecule of oxygen is present. And in sample B, 1 mole of oxygen molecule is present. So what is the ratio of number of molecules in both the samples? As I told you, 1 gram, 1 mole or 1 atomic mass unit is always equivalent to Avogadro's number. So therefore, in both the samples, whether it is A or B, they contain same number of molecules which is equivalent to Avogadro's number. And the ratio is 1:1. Because as we know that atoms, 1 mole of atom, 1 mole of molecule or 1 mole of particles. In all the cases, they are equivalent to Avogadro's number. So that's why in both the samples, whether it is A or B, it is equivalent to Avogadro's number. The next is, what is molar volume and what is its value? Just now I told you, if we want to calculate the number of moles in gases, so it is very difficult to find out the gases volume. So if you want to measure the volume of gases, the easy way to find out the number of moles of that gas. So how can we find out? We can find out by this. 1 mole of any gas is equivalent to volume of gas, which is in centimeter cube, and 22.4 liter at STP. That is standard temperature and pressure. So the volume occupied by 1 mole of a gas under standard conditions of temperature and pressure. This is 273 Kelvin temperature and it is 1 atmospheric pressure. So these are the standard conditions, because if we increase or decrease the temperature, there is a change in the volume of gas. So that's why we always take STP. So that temperature is 273 Kelvin and pressure is 1 atmospheric pressure. So at STPs, the value of the this molar value is always equivalent to 22.4 liters. Now calculate the molar mass of sodium sulfate and calcium carbonate. So if you know the formula, then just write down this formula, although it is given in the question also. Sometime in place of question, they'll write chemical name. So you know these formulas. And by practice, if you do more and more practice, you can easily learn these formulas. So first is sodium sulfate. Now, first look at the elements which are involved in this compound. This is sodium, sulfur and oxygen. So 2 into mass of sodium plus 1 into mass of sulfur, because it is present 1 here, plus 4 into mass of oxygen. And masses are given here. You need to learn all these masses of elements till atomic number 1 to 20. So you need to learn all these atomic numbers, their elements, symbols and atomic masses. Then only you will be able to solve these kind of questions. Now after writing their masses, sodium, it is 23. If you look at this table, it is 23, and mass of sulfur is 32 and mass of oxygen is 16. So when you solve it, it is 46, 32, 64. And when so you'll solve it, it becomes 142 AMU, or you can write grams. Okay. Now molar mass of calcium carbonate. If you find out the molar mass of calcium carbonate, again the same method you'll use. Mass of calcium, mass of carbon, mass of oxygen, and just see how many they are present in numbers. So simply write down this here, 1 into 40 plus 1 into 12 plus 3 into 16, and we'll get 100 answer. So we'll write this molar mass 100 grams. Okay. So this is how you'll find out the molar mass. Now, next question is identify the cations and anions in the following compounds. The compounds are given and you need to segregate which one is the positive one and which one is the negative one. So if you look at this, Na is positive and CH3, COO is negative. Here NH4Cl. So NH4 is positive and Cl is negative. Then SrCl2, Sr is positive and Cl2 is negative. So these kind of questions can also come in the exam. You need to identify the cations and the anions. Now calculate the total number of electrons present in 1.6 gram of methane. So here you need to find out the total number of electrons. It means particles. Okay. So first of all, we need to find out the molecular mass of methane, which is 1 into C plus 4 into H. Because carbon and hydrogen, these two elements are present. So atomic mass of carbon is 12. Look at this table, and atomic mass of hydrogen is 1. So we'll write 12, 1 into 12, you can write like this, or 4 into 1, and we'll get 16 gram. So 16 gram is the molecular mass of methane, and 16 gram of this methane is equivalent to 1 mole, and 1.6 gram is equivalent to 0.1 mole. And 1 mole of methane is always equal to Avogadro's number, which I have already discussed. Again, 0.1 mole is equivalent to 6.02. So whether it is atom, molecule or particles, they are always equivalent to Avogadro's number. So 1 molecule of methane contains 10 electrons. How? 6 plus 1 into 4. So this is atomic number of this carbon is 6, and here atomic number of hydrogen is 1, but 4 is also given. So we'll multiply with this 4 and we'll get 10 electrons. So 1 molecule of methane contains 10 electrons. And we need to find out the total number of electrons present in 1.6 gram of methane. It is one molecule. Okay. Now, this 6.022 into 10 raised to power 22 molecule will contain 10 into Avogadro's number. Just simply multiply this with Avogadro's number. So, this much of electrons are present in this, because this is equivalent to 1.6. So, I hope this question is clear to you. So, how you will find out the number of electrons. Now, what is the mass in grams of one molecule of caffeine? You need to find out the mass in grams. So, first of all, we need to calculate the gram molecular mass. Again, 1 mole of caffeine molecules is equal to gram molecular mass. And how will you calculate? Let's see here. First, I'll write, it's easy for you so that you can understand. 10 into H plus 4 into N plus 2 into O. Just write down in place of C, H, and O their atomic masses. This is what we have done here. 8 into 12, because atomic mass of carbon is 12. 10 into 1, atomic mass of hydrogen is 1. 4 into 14, atomic mass of nitrogen is 14. And 2 into 16, atomic mass of oxygen is 16. So by simply, after solving these, we'll get 194 gram. So this is a 1 mole of caffeine molecules contain 194 gram. Then 1 mole of caffeine is equivalent to Avogadro's number. And if we need to, so it means this Avogadro's number is equivalent to 194 gram, which we have done earlier also. So we need to find out in one molecule. So simple as that, 194 upon Avogadro's number, and we'll get the answer. Now, next question can come in exam is, what are the failures of Dalton's atomic theory? Here you need to write its limitations. As we have discussed earlier also, there were some flaws in the Dalton's atomic theory. So those flaws are the limitations or the failures of Dalton's atomic theory. Let's see what are those failures. Like he said, atom is the smallest particle, but atom is not the smallest particle. Although subatomic particles are also present in it in the form of protons, electrons, and neutrons. So this is the first limitation or the failure of Dalton's atomic theory. Then atoms can be transformed to energy and hence can be created and destroyed. So now third is, atom of one element have been changed into atoms of another element through artificial transmutation of elements. And atoms of same element need not reassemble each other in all aspects as isotopes exist. So when it is a case of isotopes or isobars, his theory failed there. So these limitations we have already discussed when I was explaining Dalton's atomic theory. So here, this is 3-mark question. You need to write all the limitations of the Dalton's atomic theory. Then next question can come in exam. Write the formulas for the following and calculate the molecular mass for each one of them. Then first is caustic potash. Caustic potash, the formula is KOH. Again, see how important this table it is. Now, whenever you want to calculate molecular mass, atomic mass, you should know their atomic masses. So here KOH is the formula of caustic potash. How can you calculate its molecular mass? Just write down their atomic masses. K is 39 plus oxygen 16, hydrogen 1, and we get 56 gram. Okay. Then we have baking soda, NaHCO3. Now see, so many compounds, so many chemical formulas are there which we have already done in previous chapter. So this is sodium hydrogen carbonate. Then sodium plus hydrogen plus carbon plus 3 into oxygen. So answer is 84. Then we have calcium carbonate. 40 for calcium, 12 for carbon, 3 into 16. So we'll write for oxygen and we'll get 100. Then we have ethanol. 2 into 12 for carbon, 6 into 1 for hydrogen, and 16 for oxygen, plus 1 for hydrogen again. So we'll write this one. So this is how we'll write the formula. Okay. Then we have NaCl, sodium and calcium. Then we'll get this answer. So as simple as that. So it is very easy for you to write down the molecular masses if you know their atomic masses. Then calculate the number of particles in each of the following. The first is when 46 grams of sodium atoms. So first I'll find out the number of particles in 46 grams of sodium atoms. Number of atoms. And the formula of number of atoms is given mass upon molar mass multiplied by Avogadro's number. So given mass represented by small m, molar mass represented by capital M, and Avogadro's number represented by NO or N dot. So N is equal to given mass is 46, which is already given in the question, and the molar mass of sodium is 23, then multiply by 6.022 into 10 raised to power 23, which is Avogadro's number. So we can write like this, 123 into 6.022 into 10 raised to power 23, and we'll get these number of particles in each of the following. Fine. Now number of molecules. Here 8 gram oxygen molecules. Number of molecules from mass. So number of molecules, again atomic mass of oxygen, so we know that it is 16U, and molar mass of oxygen, which contains 2 molecules, then 16 multiplied by 2, which is 32. Again we'll use this formula, given mass upon molar mass into Avogadro's number. Then here 16 multiplied by 2 is equal to 32. So here I have written given mass is 8, molar mass is 32, multiplied by Avogadro's number, and we'll get this answer. The next is 0.1 mole of carbon atoms. Number from given moles. So number of particles is equivalent to number of moles of particles multiplied by Avogadro's number. So we'll use this formula. So we need to find out the number of particles, number from given moles. Then we'll use this formula, which is number of particles multiplied by Avogadro's number. Simply number of particles is given 0.1, and Avogadro's number, we know that, we'll get this answer. So here, so these are the questions which I have discussed with you according to exam point of view. Now apart from this, I'll discuss few more questions. For example, if you need to find out how many, I'll write this, just do this question along with me. How many grams of sodium will have the same number of atoms as 6 grams of. Children, I am giving you this question. Please solve it. Of magnesium, and write your answer in comment box. And here Na is 23U, it is given, or Mg is equal to 24U. How many grams of sodium will have the same number of atoms as 6 grams of magnesium? So you need to find out. So how will you solve this? First of all, we need to find out number of moles of sodium. How will you find out number of moles of sodium? Mass of sodium upon molar mass. Okay, then mass of sodium is given, and similarly number of moles of magnesium, given mass upon molar mass. Now, in this way, we can find out mass of sodium. Okay. Now, find out by using these formulas. Just try to solve this question and write your answer in comment box. So, given mass is equal to 6 and molar mass is 24. So, it is 1 upon 4. If you solve this, it is 1 upon 4. So, number of moles of sodium is equal to 1 upon 4. Number of moles of sodium is equal to mass of sodium upon molar mass is equal to 1 upon 4 is equal to mass of sodium divided by given molar mass. Okay. So now mass of sodium is, if you need to find out how many grams of sodium will have the same number of atoms. So mass of sodium is equal to 23 upon 4 is equal to 5.75 grams. Okay, so this is how you'll solve this. So it means 5.75 gram, here it is, 5.75 gram of sodium will have the same number of atoms of 6 gram of magnesium. Now another question is, how many moles? I'm giving you this question as a homework. Solve it. How many moles are present in 4 gram of sodium hydroxide? This is your homework, and try to solve this, and if you know the answer, and write your answer in the comment box. Hint I'll give you. First you need to write find out its gram molar mass. So you need to find out the gram molar mass of this NaOH. Gram molar mass of NaOH. Then you can easily find out. Okay, so this is your homework. Solve this question